Okay, we're back, and we did a series of tests in the last movie, probably half an hour of tests online that you guys saw the effects of, which is kind of neat, but definitely unnecessary. So we're back. It's COMP100. It's week 8, lesson 8, part 3. We're talking about using arrays for this latter half of the hour. We got 1 hour to do this, and we'll do more next week. We get together. So what are arrays anyway? I keep saying array, array, array. But we're going to talk about these things a little bit. So again, array, as the definition is, a list of items, data items, that all have the same type. So think about a bunch of integers, or a bunch of doubles, or a bunch of strings, right? And the same name. They all have the same names. Each item is distinguished from the others by something called an index, right? And here's how we declare and create an array. Double, with these square brackets. Take a look at the syntax. Sales. Sales is a double array, right? Here's another one. Here's another way of doing it. There's 2 ways to do this thing here. Sales, then, is a new double, right? This is the second piece to it. So this is declaring the array, double, sales. And here's creating the array. There's 2 piece parts to this, right? New double array of 20 elements, right? We need to use the new operator when creating this thing. There's actually different ways of creating the array, but this is definitely the most common way. Now you can do this all in one line. You can say double array, a double array that's called sales, right, is equal to a new double array of 20 elements. If I have 20 elements, how do I count these 20 elements? Well, we count them. We call most C-style languages use zero-based indexing, just like we do with, we start from 0, in other words. So we start from 0, 1, 2, 3, all the way to 19. If I have 20 elements, I go from 0 to 19. Okay? We start counting at 0 for all arrays in C# and other C-influenced languages. An array element, then, is each object or space inside the array. So think about an array as a stack, right? A stack of elements, right? So when we talk about a stack, let's draw one out for ourselves, okay? So I'm going to go into design here. I'm going to draw up fireworks for us. It's just almost like drawing on the board. Let's try and do this together. I'm going to go File, New. I'm going to make an object that's 500 by 500 pixels for our little demonstration with a white background. Okay, here we go. I'm also going to kind of zoom in here a little bit. Okay, tell me if this makes sense to you. Oh. There we go. All right, so an array then looks kind of like this. You can visualize it like this. If I have one cell, here's one cell in my array, right? And let's make my cell so it doesn't have a background at all. So we're not going to make it gray like this, right? I'm going to give it a border, a black border, let's say of 3 or 4. Here we go. There's our cell. And inside of our cell, right, instead of it being filled up, we're just going to make it so that it's nothing. This is one of our cells. So this is what maybe a variable would look like. It's a container with something inside of it, right? Well, an array is kind of like that. But what I can do with it is do one of these. So here's an array of 2 items. Take a look. It's the array itself has a name, right? So typically we have a variable name, and the variable name is called, I don't know, it's a certain type. So let's say my type is integer, and my name for the variable is number 1, right? So I can do this typically for 2 different cells that are unrelated, right? So I'm going to make this a little bit bigger for you to see. Here's number 1, and here, if I put this down, is number 2, right? They're both integers, right? And they're both separate. Would you agree? Two variables, 1 and 2, right? But if I have an array, I actually group them together like this. So put these two cells together, and I don't need the second naming. I just have to do this. It's now an integer array. I use the square brackets to indicate that it's an array of numbers. Right? Typically, when we think about arrays, there's more than one element. So we don't say when we create our variable names for the array, we don't use a single name. Like for example, if I was going to make a person variable, if I have a bunch of persons variables, I would call them people as opposed to persons. Like one person, 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 person 1, person 2, person 3, person 4. I'm going to make a people array. Make sense? So this way, instead of number 1, number 2, number 3, number 4, I'd make a numbers array. Numbers. Now this index in the array, right, we're talking about zero-based indexing. When we start counting the index to the array, this is index 0, right? We start counting like this, index 0. And then we go to index 1. Right? We never count by 1. We don't start at 1 for the array. And when I count the next one, so I'm just counting the cell. This is not the value in the array. This is just the index. It's almost like I'm pointing to which one. So the 0th one, the first one, each of these cells in the array has almost like an index. A subscript is what they're called. Let me just do a couple more of these so you get the idea. That's really slow. So you can tell when my Mac is lagging because I've got all kinds of stuff going on at the same time. All right, so here's number 2. Oops, here's number 2. And this isn't the value in here. This is the index. Okay, so this is, I'll put that in there so we all can see that. So here, I'm going to kind of make a new thing. And I'm going to say the index is 0, 1, 2 for my array, right? I'm going to copy this now. And I'm going to pull this aside. Right? This is my index, but this is my value. My value is different. My value can be whatever I want. 0, right? Make it 10. This could be a 2, or this could be a 12. This could be a 3. My value could be all different numbers, right? That's the actual value that's inside, that each of these elements contains, right? But when I start pointing to them, if I want to refer to them, the 0th one, the first one, the second one, the third one, it keeps going like that. It starts at 0. And how many elements are in this array? So if each one of these indices points to an element, how many elements are there in total? Heidi, how many elements are there in total? If not, this is the value of them, and this is the index. How many elements are there in the array? No. I'm only pointing to the index here, right? So if I was to take these boxes away, it really looks like this. How many elements are in the array? 4, right? This is the pointer. 0 is the pointer. It tells me the address for this element is 0. The address for this element is 1. The address for this element is 2, and so on. That's what it is. Each of these elements are part of the numbers array. We use one variable name to refer to this whole thing, but we use these indices inside the square brackets to indicate which one of the numbers we're pointing to. Like a table, but we're pointing to which one of the which one of the elements in the array. So there's 1, 2, 3, 4 elements, but the addressing or the subscript or the index, whatever you want to call it, there's different names for the same thing, of each of the elements. It starts with 0, 1, 2, 3. So if I pick the first element, it's going to be this one. That's the first element. This is the 0th element in computers. 0th, zeroth, right? And so we use zero-based array counting. That's how we do it. And again, this can have, in terms of how many elements you can have in your array, truly it's not really limited. You can have as many elements in your array as you want. But, and here's the big B for but. By the way, I want you to learn something. If I ever tell you but, you know what it means? Behold the underlying truth. But it means that everything that I just said, forget about it. This is the real truth right here, right? So if I say something like this, man, you're really beautiful, but, right? Man, you're really smart, but, right? It means forget what I just said. The next part is what I really mean, right? So if I say this, if I say, you can make it as large as you want, but, you know, within limits, right? And the reason why is because if you make arrays of 1 million elements, it's crazy, right? They do have limitations, but for our purposes, for the most part, if you make 100, 200, 500 element arrays, it's no problem. Okay? How do we use these things anyway? Well, let's take a look. So we're going to go back into our PowerPoint for a second. So we're describing what an array is. So again, we use these array elements, or each of these cells in the array, right? Subscripts, or indices, index, kind of refer to which of the elements I'm pointing to. And again, we're beginning with the number 0 because we're in the 0th element. Sometimes we get this off by 1 error because, you know what, we start counting at 0 and we want to do a number between 1 and 10. Think about the assignment number 2 that you're doing, or number 4, part 2. You're doing an airline and you have 10 seats and you want to represent them with an array. You're going to make an array of 10 elements, but the array is not going to start with 1. It's going to start with 0. It's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Seat 1 is actually 0. So this is where you get this off by 1 issue, where we think about it and we're saying if we're looping from 0 to 9 or from 1 to 10, we can do that, right? We really mean to loop from 0 to 9 because of the zero-based counting. People have this problem.
9 arrays in that case.
No, 0 to 9 is still 10 elements. 0 counts as 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 to 9, not 1 to 10. Right? Still 10 elements, but we're counting from 0. Right? So be cognizant about, think about those things. When you use arrays, when we use for loops to loop through arrays, right? Which is a lot of times what we do, we have this problem where we are off by 1. Okay, so this is an example of a bigger array, right? So we have a 0, 1, 2, and this is how we look at it. If the array is called sales, and the array holds integers, here's some, well, these are memory addresses, but each of these addresses, I mean, if you notice, because each of these sales is roughly, they're all integer sales, right? Let me just go back to see what the integer we made. Is it an array of integers or arrays of doubles? I don't know if they're accurate here. But what they're saying is each of the memory locations, each memory slot takes about 8 locations or 8 bits. Not so sure. I think it takes more than that. But when it comes to counting, if I want to look, if I say sales 0, I'm referring to the 0th element of the sales array. Sales 1 then would be the first element, or the 1th element of the sales array. And this is the second element of the sales array. Element 2, or index 2, or subscript 2. It's all the same. Okay? Even though this is actually the third element in the array, we're talking about it being the second, right? Because it's 0, the 0th, the first, the second. Where actually in real life it would be the first, the second, or the third, right? We can't count from 1, we count from 0 in computers for most C-influenced languages. C#, C++, JavaScript, Java, get used to this counting method. You might say, well, it's not intuitive, it's unnatural, but actually it is, because 0 counts for something, right? There are some languages that start with 1, by the way. Okay.
Which one language?
I believe it's not VB. There's another language that does that for like non-zero-based counting. I'll find out for you in the break. Assigning a value to an element, an array element. So here's what am I doing here? I'm saying the 0th element of the sales array is having a value of 2100.00. I'm assigning 2100.00 to the 0th element. So what I'm saying is, going back to my drawing, this is the 0th element. I'm going to put in here, and the value is going to go in here is 2100. That's what I'm actually doing. The value that's being held in the 0th element, this is the 0th element, or the numbers array, let's say, where this is just called sales in the example. Here's my sales array. And instead of an integer array, it's a double array, right? So 21.00, right, is being held inside this array element in here. And let's make these other elements actual doubles. Right? We'll make this 1.01, and this one will be 0.3. These are all possibilities, right? So here we are inside my double array. I've got in this particular example that's here on my drawing, I've got 4 elements. The 0th element is 2100.00. The first element has 10.0. The second element has 12.01, and the third element has 0.3. They're all valid values for a double array of sales. Right now, obviously, if it's sales, it's probably going to be one of these. That's more accurate, and one of these. Because if it's sales, we're talking about dollars. Now, we can't store dollars. We can only store numbers, because dollars would be a string, and we're only looking for double values. So it still has to, these are all doubles. When you declare an array, all elements of the array have the same data type. Integers, doubles, strings, whatever. Okay? I also want you to think about this. In the future, we're going to make our own data types, whatever we're going to call them, right? And so then these elements are not going to, these containers are not going to just hold numbers, simple numbers like this, but they can actually hold objects of any type. They can even hold other arrays. So I can make an array of arrays, right? Like for example, instead of a value being in here of just a double, I can make it a, this is by the way called, this is a single dimensional array. This is the idea here. So we're talking about a single dimensional array because it goes 0 to 1. We can also make a double dimensional array, a two-dimensional array. Two-dimensional arrays have 2 indices. They have row and column, right? So I can do one of these.
So what's an example of an object?
Hold on. So there are many different kinds of examples. Here's a double, a two-dimensional array. Watch. We'll go Control C, Control V, and where I have my indices, instead of doing this, I do this. So a double two-dimensional array, which you might see sometimes as well. For example, if I wanted, and it's just the way we represent it. So my index is 0 for this element and 0 for this element. But this has, as an example, it could go, here I'm just going to go, let's try this. This is more realistic. Index 0, index 0, index 0, right? And the second one is index 0, 1, 2, 3. So index 0, when I index it, I only have these elements, right? But the way I index them is different. So watch this. Just going to get rid of this. There's still only one value that's being held. It's just multiple indices, right? So I go index 0, 0 is 2100. Index 0, 1 is 10. Index 0, 2 is 12.01. Index 0, 3 is 0.3. That's a two-dimensional array where you can create a matrix. And I can make a three-dimensional array, four-dimensional array, five-dimensional array, however many dimensions I want. Caution, the more dimensions you use, the slower and slower the computer gets. The fastest arrays are single-dimensional arrays. One big line, right? And we have to think about how to, typically using multi-dimensional arrays, more than one dimension, is discouraged. Unless you want to represent something in business where you need multiple dimensions. Let's take a look at that a little bit closer. I know you guys are thinking, what is he talking about?
Yeah, I'm confused.
Good. So C#, again, arrays are instances of a class named system array. System array is the base class for all arrays, which means that if arrays are instances, just like you're creating other objects, right? When we use the new keyword to create an object, we use the new keyword to create special objects. The new keyword creates objects, not just data types. They're complex data types. Arrays are complex data types. So far we've been doing simple data types. Double, integer, string, all those are considered like simple data types. Arrays are complex data types, and they're actually considered objects. Each object has methods associated with them that you can do for an array, right? So here's an example. If I want to initialize objects, here's my numeric fields is 0, my character fields or null, my Boolean fields false. This is the way I initialize the object. If it's a numeric field like integer, double, blah, blah, I initialize them with 0. My character fields, I use a character or null, like for example, strings. Boolean fields, I can initialize them with false. That's their default. Okay, and again, an initializer list is a list of values provided for an array instead of declaring the values afterwards. We'll talk about that in a second. Here's an example of some initializer lists. So there's different ways of declaring arrays. I can declare an array like this up to here. Take a look. Up to here. I can say int array, integer array, it's called myscores, is equal to new integer array of how many elements? 5. 0, 1, 2, 3, 4. There's 5 elements here. And what I'm doing here afterwards is I'm actually declaring what each of these elements are in terms of value. So I'm saying element 0 is actually 100. I'm actually assigning, by using this notation, see where the semicolon ends? That's the whole line here, right here. So the 0th element, I'm making it 100. The first element, 76, 88, 190, right? I'm doing that. But I'm telling it right off that I have a number of elements in my array, 5 elements. I'm telling you right away. That's one way of doing it. Here's the second way. I don't tell you how many in here, but I put them in here, right? It's the same. This one and this one equivalent, because I'm declaring what they are right here. So I know they're going to be only 5 of them. Here's the third way. Forget this new int. I'm just going to use literal notation. Take a look at it. 1, so 0, 1, 2, 3, 4. Still have 5 elements. It's all equivalent. Here's the thing with arrays. When you declare the length, how many elements are in the array, in C#, that can never change. Once I declare how big the array is, it's fixed forever. It's immutable in terms of how many elements. However, I can change what's inside of the array. Each element can have its own value, right? But I can't change the number of elements in my array. Okay? So keys. These are keys to understand. I can use a for loop to loop through the array. So here's my integer variable subscript. I started off at 0 because we're using 0-based counting. I don't have to. I can start off at 5 and count backwards, right? Oops. There we go. And I check to see, my condition is if my subscript is less than 5, right, then increment my subscript. So I start off my first line. This is badly written, by the way. You need curly braces here. But you say my scores array, subscript would start off at 0. So the first 0th element, I want that to increment that 0th element by 3. So take the 0th element and say, it's like saying plus equals to 3 is like saying my score sub plus my score sub is equal to 3. That's what this is. So when you see plus equals, it's a shortcut to say my score sub is equals to my score sub plus 3. I'm saying it different ways, but same thing. At the end of the day, you can loop through the array by using this square brackets indexing method, right? This number in the square brackets I can use instead of a literal, I can use a variable. So it allows me to loop through the entire array. Do you understand that? Am I losing you? We're going to do an example in a second.
Yeah.
Okay. One more thing. The array, each array, because arrays are objects and they're not just data types, right? They have something called an array, a length element, a net length property. So arrays don't just have values. You can actually look at the actual array itself, not the individual elements, but the array variable itself, the name of the array. So let's say my array is called sales, right? I can check how many elements are inside my array by using the length property, right? So I can say my scores dot length. I use the dot accessor method. How many objects or elements are inside of my scores? Well, inside this scores we have 1, 2, 3, 4, 5 elements. So this my scores dot length is going to return the number 5. So we're going to say here's my for loop. Int x is equal to 0. Check to see if x is less than 5, x plus plus. So what it's doing, it's going to print out 1, 2, 3, 4, 5 times my scores. Each of these scores is going to come out. Let's try this, because I'm talking about it, but we're not doing it. Let's do it together. And then we'll stop for the day. We're here to 10:30 anyway, but let's try it anyway. Okay, so here's a new project. We're doing a third one for today. Wow, we're going crazy with projects today. COMP100, right? Lesson 8, part 3. Okay, I'm going to press OK. And I'm going to create my new project. I'm going to go into GitHub. Here's GitHub. And in GitHub, I'm going to go to create a new repository. I call COMP100, right? Lesson 8, part 3. Right, there's lesson 8, part 3. I'm getting my URI for GitHub, Control C, right? And I'm going back into my Visual Studio, changes, created VS C# or base VS C# project. Commit, home, unsync commits, put in my URI in here, and publish. Cool. Now, I'm not going to copy that stuff I already did, so I'm going to go into GitHub, and I'm going to go into my COMP100 lesson 1 part 3, into my lesson here in program. Oh, wait. Part 2. Where's part 2? Did I lose it? I don't know, but I'm going to go into part 2 here anyway. Part 1. And I'm going to grab this part because I don't want to do this again. I'm lazy to type. Okay, so I'm grabbing this, and now I'm going to do an array. Let's declare, a numbers array. So I'm going to say int array. That's how you declare it. Int square brackets, like this. So the way we read this is we say an integer array. That's how we say it. Integer array of, what's it called? My numbers. The my numbers integer array, right? If I just do this, have I declared the array? All I've done is saying that, my numbers is of type integer array. It's an integer array. But I haven't created the array until I use, there's a couple methods. I use the new keyword. So this is the first way I can do it. Equals to new integer array of a fixed number of elements. For example, 10 elements. Right? And if you notice, the squiggly red line goes away. That make sense? So what am I saying here? I've got a number array, an integer array of 10 elements, 10 numbers. But instead of doing my number 1, my number 2, my number 3, my number 4, I'm doing my numbers is equal to 10 elements. I'm declaring how many elements. That's one way. Here's another way. Instead of doing this, right, I can actually declare the elements. So I can say my first number is 5. My second number is 13. Third number is 45. Fourth number is 10 or 20. 1. And then 0. It's also a number. Right? I can also do negative numbers, negative 5. Those are all valid. So inside the curly braces, I'm declaring a list of numbers, and each number, I've got 1, 2, 3, 4, 5, 6, 7. I need 3 more to make it 10. Let's say I can make how many I want, but let's say, and I can even have duplicates like 1, 1, 2, 2. Right? Those are all valid values for each of the elements. 3, 4, 5, 6, 7, 8, 9, 10. Actually, this is even more efficient than doing that because what I'm doing is not only declaring 10 elements, but assigning their values. Right? So this is more efficient. If I know what the values are of the array, I can do it this way as well. Let's do it this way for a second from an initialization. This is called an array initializer. Right? This is called literal notation. Literal notation allows us to initialize an array of elements like this. Okay, if I want to loop through the array then, I can use a for loop. For, dash, dash, and I can do one of these. I is equal to 0 to I is equal to my numbers dot length. Because the length property that belongs to my numbers, as an example, it reads how many elements are inside the my numbers array. And then I can do a console write line, right, of the my numbers array. So I can go my numbers, and I use a square brackets to index it of type I, right? So I'm saying take the I, which is the variable, put it inside this as an index, and I'm going to say, so I'm going to count. We'll start counting. For I is equal to 0. So now it's my number 0. What's my number 0? What am I pointing to? What value? This is my list of numbers. What's my numbers 0? No. It's 5. Because I'm counting like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 numbers, starting with the number 0. I'm not looking for the value. I'm looking for the index. When I put the number in here, it's the index that I'm looking for. Now I'm saying, if I look at this, instead of my numbers, let's just change this idea so we can understand almost like addressing. I'm going to refactor this, right click, refactor, rename, and I'm going to call this houses. Right? Okay? If my number's houses, and I go house, my houses each has a value, right? As an example. And let's change these values so that way, let's just say each house in terms of 100,000s. Okay, so I have a house that's worth 400,000. I have a house that's worth 500,000. I have a house that's worth another $400,000 house. I have a $300,000 house. I have a $700,000 house. I have a $1.3 $100,000 house, 1.3 million, right? Let's say $900,000 house. I have an $800,000 house. I have whatever. So 1, 2, 3, 4, 5, 6, 7, 8. 2 more. 4, and maybe a 3. We found a $300,000 house somewhere else. Okay, in terms of 100,000s, right? So if I do this, if you notice, there's some repeats, right? That's okay because they're just individual values. They don't have to be unique. The values of the cells, they're just individual. Think about them as individual elements that I've grouped together under one name, houses. Yeah.
If you change I equals to, let's say, 3, that would be the value 3, correct?
0, 1, 2, 3. Right. Get it now? So if I run through this list, if I run this for loop, what is it going to do? It's going to print out each of these values in a line. Let's check this out. Print. Bang. Let me just make that bigger so you guys can see it. Right? So you guys can get this. We got to practice a bunch with this so you understand what we're doing, because if you don't get this part, you're going to be lost when it comes to the other stuff. Hold on.
One more question.
Yeah.
Okay, so remember how before you were doing mutant and then you just put 10 instead of making individual unique ones? So if you were to do 10, that would be 2.
0 to 9 is what it would be. But let me explain this to you. Here, I'm not declaring here and here. I'm not declaring how many values I have. I'm just creating the values. When I create the values, something happens. Type inference happens. I don't know how many integers I need, right? C# doesn't know, right? You've got to allocate, put memory aside for how many variables I need to group together in my houses array, right? I'm using a different language here, okay? I can do it a couple ways. This is one way where I assign all the values, okay? Here's the other way. I'm not going to assign the values here. I want to go new integer array with 10 values. Okay, if I do this, what are the values of my houses right now? Do they have values? No, because I haven't initialized them yet. In order for me to initialize them, I have to put them inside of a list. Now there's different ways I can do that. I can do it like this. I can say, I've declared how many there are. Now I have 10 elements, and I could do something like this. Houses is equal to, can I do this again? Can I go, let me go back to that way, 4, 3, 5, 7, 3, 4, 4, 8, 2, 1, $100,000 house. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can I do that? Can I initialize my array of houses with these individual items? The answer is no.
Wouldn't it be 10?
0, 1,
No,
2, 3, 4, 5, 6, 7, 8, 9, one more, 10.
I'm saying,
Can I do that?
Saying if you put, I don't know if you can see. If you make this equal to this.
Could I do that? Yes, I could. I could do, at the time of declaration, that's the only time I can use this initializer. I can do this.
Yeah, that's
This I can do, right? To make sure that I have enough elements there, right? This is an array initializer of length 10 is expected, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got too many elements.
that works.
This is okay. When upon declaration, you can do this.
Is that more
I can
efficient?
tell you how many, not really. I can tell you how many there are, and I'm limiting myself to how many. Or, I don't do this, and I do it later, like this. This is inefficient, but I could do something like this. Houses 0 is equal to 1. Houses, no, but I may have to do this. Houses 1, right, is equal to 25. Houses 2, right, it's big, is equal to 5 or 4. Houses 3 is equal to 5. And keep going. And houses 4, right, is equal to 4. And then I can do a little loop. Right? Watch this. I can do a little loop that says I want to go from 5, here's my index, to less than the string length, houses dot length, right? And I want to initialize the rest with 0. Houses 0, or houses I, sorry, is equal to 0. So what's going to happen here? Right? I have initializing some of them, and then in a loop, I'm starting off at the fifth index. So 0, 1, 2, 3, 4. And I'm going between the fifth index and whatever indices are left up until and not including the last index, the last number. So I'm going to go from 5 to 9. So from elements 5 to 9 are all going to be 0, and the other ones are going to be this. Let's check this out. Bang. So here's my numbers. Let's take a look. 1, 25, 4, 5, 4. 1, 25, 4, 5, 4. And the rest are all going to be zeros.
So what's the benefit of using arrays?
My God, there's so many benefits. Right?
What would
Instead of me having number
use the
1, number
variable?
2, number 3, number 4, number 5, number 20, number 30, number 50, I have 50. I'm going to declare 50 individual variables, or I can declare one array where I have 50 elements. Right? There's so many good reasons for it. And we can do a lot of really cool things with it. Like, we can deal some cards. Right? I can make an array of 52 cards, 52 elements. Each element of the array, right, has a code. It's a string array, and the array's got two things in there. I can create an array that has the suit and the face. So what's this? How many suits are there in an array of cards?
4.
4 suits, right? Clubs, diamonds, hearts, and spades. I made them up like, really quick. And how many card faces are there? There's a 1, a 2, so actually it's an ace. A 1, a 2, a 3, a 4, a 5, all the way to king, right? So there's 13 cards. Really, there's 14 cards because you can count the ace twice. 1 for 1 and 1 as a 14. But there's only actual 13 cards, right? Physical card 13, but you can ask an ace can be both values.
Yeah.
Kind of weird, right? Depending on the context. So if that's true, if we're going to do a card simulation really quickly with this in this particular case, first of all, let's do that. So I would have to initialize my value. So I'm just going to get rid of all this for a second. And let's say we wanted to call it cards, right? So as a cards array, my cards, I have 52 elements in my cards because I have a 52 card deck, right? I have 4 suits. Let us use, kind of talk about what the suits are. So I want to say I have a suits, I have 4 different suits. Now I can use an enum for that, right? Could I not?
Yeah.
Each suit being a different value, right? I could do that. Or I can create some values, if you will, right? So let's start off like this. I want to make a suits array. So I'm going to make a string array, right? Here's another array of suits, right? And I'm going to initialize this array right away. I'm going to make it so that it starts off each string array. It's going to be a single character string, right? So I can make a character string of 1 or more characters. So my character string is going to start off with clubs, right? And then I can say my second character is going to be diamonds, right? And my third one, hearts in order, and spades, right? Those are my suits, right? Now look what it says. It says, cannot implicitly convert type char to type string. Because typically, if you look at it, each of these elements, right, are type char because there's only one element in here. If I want to, I could say, which is better, clubs, right, diamonds, hearts, and spades. Can I do that? Now it says, look, it says too many characters in a character literal. Not really, because I'm using these single quotes instead of double quotes, right? Making a string array like this, I need to use double quotes instead of single quotes, right?
That's the
I would have fixed it. Heaters. For heaters. Not haters, heaters. I could do this. Right? So I've got my, and let's make them capitalized too. So if I do it, I'm going to go to spades. Oops. guys are gonna watch paint peel with me, man. I'm crazy. So spades, let's make that the first one capitalized. Hearts, diamonds, and clubs. Okay, cool. So I've got these, right? Clubs, diamonds, hearts, and spades. These are my suits. And I've got my numbers. Now I got to initialize my numbers from 1 to 52, right? 1 to 52. I got 52 elements. It goes from 0 to 51, right? But I want to go from 1 to 52. So if I want to initialize my elements, so here's my, I'm going to put this in, initialize, and instead of cards, right now I'm going to call this faces. So here's my faces integer array. Initialize faces array, right? Here's my faces array. And my faces array is going to be from 1 to 52. So I'm going to go 4. I'm going to start doing this. I'm going to start my index, right, is going to start at 0 and go to to 52. Let's go just do 52 here.
I have a question. This is really random, but this program, like Microsoft Visual Studio, what program is it written in?
It's written in C, probably, if I'm not wrong, in C++.
There's so much programming.
Well, some of the things you can do in here, yeah.
Like see how you were like.
Oh yeah, man. So it's called IntelliSense, right? Okay, cool. So I got my index 0 until my index is less than 52. Do my index. Well, if I want to initialize, listen to my words, guys. Initialize my faces array. I got to do something like this. Faces, then index. The index of faces is equal to what? My index plus 1. Why? My index starts at 0, but I want to start my card counting at 1. I'm going to go to 51 because it's less than 52, but I want to count to 52. So I got to go index from 0, from 1 to 52. I got to do 0. This only goes from 0 to 51. I got to go plus 1. So it goes from 1 to 52. Now there's different ways to do this, right? I could have put in faces.length, but what's my faces.length? Is it 52? In this particular case, it is. I could put something like this instead, faces.length, right? That's acceptable because my length of my array has been declared as 52 elements, right? Okay, if I run this now, it'll initialize my faces. I've already initialized my suits, right? So I got my suits and my faces, and now I need an array of cards. So here's my string array. It's got to be a string array, right? String array of cards, right, is equal to a new string array 52. Okay, it's empty right now, cards, and I'm using 3 arrays here. Why am I using 3 arrays? Because the final array has got to be an array of strings. It's going to be like this: 1 of clubs, 2 of diamonds, 2 of hearts, 2 of.
So you have to make 1 for the faces, 1 for the suits, and then 1 for the cards. So
well, this is my solution.
Like a combination of both.
That's my solution, yeah, but that's my solution. But you could do it different ways. Okay, like you can do it all in one, but we're not going to do that right now. Okay, so cool. So I've done this. Now I'm going to initialize my cards. How do I do that? A multi-dimensional array, right? I could do a multi-dimensional, nested loop, right? I need to do my for loop on the outside that does my clubs, diamonds, hearts, and spades, right? And then the inside, I do all my faces. Let's try this. So I go for loop, right? On the outside, I'm going to call this suit, right? My suits is less than suits.length, right? So from 0 to suit length, 0, 1, 2, 3. 3 suits, 4 suits total, right? That's on the outside. On the inside, I'm going to do an array that's from 0 or 1 to 52, right? So it's going to be card, right? And my card is going to be cards dot length. Okay, now I could make it so it's 52 instead of coding it like this. Okay, bear with me. So kind of a nested loop here, right? And inside, I'm going to do this. First of all, on the outside, I'm going to go like this. Actually, I can probably do it all in one. Let's do it all in one. Cards. Now, here's the trick. Question for you. I'm going to start counting my cards, but my cards has to have its own counter that has nothing to do with these things, right? And here I'm going to declare a counter. So here's I'm going to say int counter is equal to, well, yeah, watch. Is equal to, it's not even gotten confusing yet. It is equal to 0, right? Okay, now watch how complex this is. Cards counter, right, is equal to, this is where the challenge comes, right? Suits, right? Counter. Well, suits is, it starts off as suit. Sorry, suit. And then that's the first thing. So it's going to be of type suit, right? Cards. And we also have to convert our number, our card number, to a string, right? Watch how we're going to build this up. So our card number, our face is going to be the same. So faces of type of faces of card. Actually, this shouldn't be card. It should say face. I'm just going to change it manually now. Okay. Okay. So faces. So the face of faces, right? ToString. Use this toString method. Don't worry if you don't understand everything at once, right? Let me make this a little larger for you so you can see it all, right? Plus some concatenating of plus suits. And the counter is going to go up and up and up every time. So we're going to do the counter, starts at 0, and we're going to go counter plus plus. So here's we got 3 loops happening at the same time. I'm counting off, my counter starts at 0. Let's run through this together so you understand what I'm doing. First, I initialize my faces so that they all become from 1 to 52. I've already initialized my suits, clubs, diamonds, hearts, and spades, right? Here, I'm running through my suit. My first suit is suit 0. Suit 0 is clubs, right? So I'm going to say, and down here, my first face card is face card 0, right? Now, face card 0 is 1, because I've initialized all my face cards, right, by 1, right? Because my faces, I start at 1. They're all going to be the same. I'm not changing their value. Faces only have 1 to 52, but I'm indexing them at 0. This is where it becomes funny. So here's 0. I'm converting it to string with the toString method. I can take my integer, converting it to string. So it's going to become a string. I'm concatenating with a plus, and I'm adding it onto this of string plus, and here's my suits array. So I'm going to say 1 of clubs. That would be the first card that I'm going to make. It's going to make 1 of clubs. And then my counter, every time I run through my loop, my counter is going to change. So it's going to be the next one, my next card. My cards in my deck, right? And maybe this cards, right, array shouldn't be a cards array. it should be a deck array, a deck of cards. Right? But let's leave it at cards. Okay, I've done all this, and now, you know what I want to do? I want to print them out. So I want to go to cards counter, and after I get my value, I want to do console dot writeline cards counter. Right? I want to do my counter. I use my counter as an individual counter that's outside of my loops, right? That doesn't have anything to do with the loops. It just increments every time it goes through the loop process. All right? Let's try this out and see what the hell I'm getting. And bam! I got an error. Let's see what my output has already though. I've got, it starts off like this: 1 of clubs, 2 of clubs, 3 of clubs, 4 of clubs, 5 of clubs, all the way down to 52 of clubs, and it never changes. Why? I made a mistake, right? Well, there's a couple of issues. First of all, faces. I shouldn't have more than 13 faces, not 52 faces. So I wanted you to catch that. So this should be 13, right? And my faces length now will run the right length of time. Let me run this again. So I'm going to run it again, and bam, now it didn't stop. Here's all of them: 1 to 13 of clubs, 1 to 13 of diamonds, 1 to 13 of hearts, and 1 to 13 of spades. Where are you going? Jeez, man. Jeez, man. No problem. Watch the video. Do you understand what I did? So this little complicated little piece of trash that I wrote here, right? The reason why I did this, I'm going to save this up to GitHub for you guys so you see what I've done. I'm just doing this little card trick that I'm doing. And it looks very complicated, but really what we've done is, on the outside, my outer loop, here's my outer loop, right? Outer loop. And here's my inner loop. That's why it's good to know loops, right? Here's my inner loop, right? My outer loop, it just changes the faces. So if I look at it, it starts off with clubs. And that's all I care about. So my clubs is what I'm doing here. Take care, Hattie. Next week. All right. So, and then my counter, I've made an individual counter or variable right here. I don't want to count within here because these things, my actual cards has to go from 0 to 51. It has to do that, right? I can't do that in here because I only got 13 in here for the number of faces, and I've got 4 on the outside. So I've got to have my own separate counter that keeps incrementing to 52. So each of my card elements, because there's 52 cards, but each card, each of the 52 cards has clubs. They're either a suit that has clubs, diamonds, hearts, or spades. So this, what this does, is it creates my deck, creates deck of cards. Right? Because what I'm doing is I'm going through each of the suit cards on the outside. There's 4 suits, clubs, diamonds. It starts off with clubs. So I start counting with clubs. Say my clubs is the first suit I'm going to take care of. And now I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, now I'm going to move to diamonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then it's going to go hearts, 1 to 13. Spades, 1 to 13. Now I'm done. But meanwhile, I've counted every time I'm doing every time I loop through the middle loop, I increment my counter. My counter is just a variable that I'm incrementing from 0 to 52 or 51, right? And that counter is keeping track of each of my cards inside the card array. That's cards, this cards array. Each of my elements inside the cards array. Because I have 52 cards. So there's multiple arrays going on. I've got 3 arrays going on, right? The array for the faces, which is only 13 faces. So I'll write this down here so you guys get it. So faces from 1 to 13, right? Suits, and here's deck of cards, right? That's what it is. My deck of cards with 52 cards, which includes 4 different suits, and each suit has numbers 1 to 13. There's 13 faces for each suit. And by the way, just as a history lesson, originally there used to be two different kinds of decks that were part of a cards. Back in the day, cards started off as the tarot deck, way back in the day. And they used to use cards for divination, to see the future, right? But eventually we played cards, gentlemen played cards in gentlemen's clubs, right? That's what they did, to gamble. And they couldn't use all of the cards because the other cards didn't make any sense. There was the two decks. There was the major arcana, which had another 26 cards. There were funny cards like Death and the Hangman and all this kind of stuff, and the Fool. And then there's the minor arcana, which is the deck that we know today. But the names of the cards were different names. They had, instead of clubs, it was batons or staves, right? And in diamonds, it wasn't diamonds, it was coins or shields, right? And hearts weren't hearts, they were cups, right? And spades were swords, right? Those are the original suits. And then over time they changed. So again, just as a thing, so we've created our deck of cards. But what if we want to mix them up? I want to shuffle my deck of cards now. How do I shuffle my deck? So I've got my deck from 1 to 52, and I want to change the position of the cards. Well, that's another story. That's really much more complex, right? But I'll put it in here as a shuffling exercise anyway. So I want to shuffle my deck. So shuffle the deck, right? How do I do that? Well, I got to use these, 2 for loops again. I'm not going to do that here. We'll leave this for another day. Leave for another day. Right? More complex. But you see how complex arrays can get. Arrays are containers of multiple variables using the same name to group them all together. Faces is the faces array that contains cards from 1 to 13. Suits is the suits array that contains these 4 suits. This is a string array. And then the cards, maybe we shouldn't call it cards, we should call it deck of cards. Let's rename this thing. I'll reformat this thing, refactor, rename, and I'll call this deck of cards. Deck of cards. Deck of cards, right, is a string array, right, that contains suits and faces. So it contains suits and faces. And the reason why we want to call it deck of cards is because it's more contextual. We know what this deck of cards is now. It's a deck of cards is different than faces and suits. It contains faces and suits, and we're building it up with these 2 methods, these 2 functions here, these 2 loops. This one loop here, right? And there's this nested loop here. Now, there's different ways to do this, by the way, guys. You could do it. I could have 4 loops, 4 of these, but instead of doing nested loops, I can do each individual loops. So I can start off and say, okay, let's initialize all of my clubs. So clubs from 1 to 13, that's one loop. And I do, okay, now I'm going to do my diamonds from 1 to 13, that's another loop. And I can do my hearts from 1 to 13, that's the third loop. And spades from 1 to 13, that's the fourth loop. So I can do them each individually. Or I can do them all at once. Any questions around this? So I'm covering a couple things at once, but we're going to go back to the easy stuff. This is the hard stuff to get. I'm going to put this back up on GitHub so you can see it. And I want you to study what this means and try and understand. If you go through loop, I want you to go line by line when you look at the stuff to understand it. Look, line 26, what's happening? When I go to line 26, I'm initializing my suit for loop, right, at 0. I'm just calling it suit. I can call it whatever I want. These elements I'm calling whatever I want, right? So my suit starts off at 0, and I'm going to loop until for as many elements as my suit length, which is the array length. 0, 1, 2, 3. There's 4 elements total. Make sense? Are you checking your code? Let me go to Team Explorer, go home, and go changes, and I'll put in something like added suits, or maybe created deck of cards with arrays, right? Commit. home, unsync commits, sync. Okay? And when I print them out, if I run this thing again, I get this. These are all the elements of my suit, of my deck of cards, each one in order. And this is perfect. I'm doing clubs first. Look. Then I hit diamonds. This is the outer loop. The outer loop is on the right side, right? Then I do hearts. And then I do spades, all in order. And then this is the inner loop. 1, 2, 3, 4, 5 to 13. 1, 2, 3, 4, 5, 6, 7, 8 to 13. 1 to 13. Over and over again. So the inner loop and the outer loop. Club stays the same, but the inner numbers changes. Just like it does, oops, like make them all align to the right. Like I can format them. I can have to figure out formatting. So I can give I can give spaces, 2 spaces for my number. I can reformat my number so it's 2 spaces. I can give 2 spaces for my of, 4 spaces actually for my of, and my largest suit, which is diamonds, I would give all the other suits. So I would have to I make an array, or a string of a fixed length. Now, if you notice, I'm using 3 different types of arrays. My integer array at first, and it's easier for me to make an integer array because I can cycle through and initialize each of the elements with numbers. Then I can convert them with this toString method. I don't know if you saw this. This toString method takes my number and converts it to a string. So now my number is no longer a number, it's a string when I add it into the deck of cards. And my plus, this plus operator, when I take this string, which is now a string, 1 to 13, I use the plus operator and say of, and then the plus operator, and then my suit, whatever it is, spades, clubs, diamonds, hearts, right? I take this whole string now and assign it to the index, my deck of cards, my card in my deck of cards. If I want to change my counter, because counter doesn't make any sense, it's not intuitive, right? What name should I give my counter? If I want to make it a contextual variable name, counter isn't correct. It's not really good. What's the better name for me to give my counter? Card. If I rename this to card, right? Then what I'm doing is I'm saying the card in the deck of cards, right? See how you read this? You look at the index first when you read the array and you say this card in this deck of cards, the first card in this deck of cards, the second card, and when I say card plus plus, go to the next card. I could actually make this card next card, right? If I can make a method, I would say next card, increase card by 1, right? Okay, let's go to the easy stuff, like I said. So we did a couple of examples here, just to finish off. There's a new loop that we can use too, and I didn't want to go here until I kind of did that little thing. I can use something called a for each loop. And what for each does is I use a couple of new keywords. For each is a keyword, and in, the word in, is the keyword. So here's what I can do. I can do this. I can say for each money in pay rate, right? Here's my pay rate. Like, look at this example. My pay rate has how many elements? How many elements does my pay rate array have? 1, 2, 3, 4, 5. Correct. So if I say for each money in pay rate, what's the value of this money variable when I start my for each loop? It's a different kind of loop. Actually, it's the 4th loop we're learning about. We learned about for loops, while loops, do while loops, and for each loops. What is the value of money when it first starts off? The value of money, 6.00. Now it loops again. 7.35. It loops again, 8.12. So this is not just an index. It actually carries the value of each individual item. So instead of me having an index, I get the value right here. How could I restructure what I'm doing over here, right, by using for each loops? Am I killing you, man? Am I killing you yet? Well, here, if I say, if I want to assign a value, look how it's doing it here. Console.writeLine, right? Here's the, I'm doing an interpolation. I'm saying my money, which is here, this is just a new element that I'm creating. And I'm converting it to string, and I'm using the C. When I put the C in string, what happens? It converts to currency. When I use this toString method takes whatever a value, a monetary value, a numeric value, and converts it to a string. Just like we use the convert, I'm going to go convert to int32. Well, when we use the toString method takes an integer or a numeric value and converts it into a string. So that's what this method is so powerful, this toString method. This? Well, you can do it that way too. But money, instead of money toString, you can go money and then you put it in here. Same thing. But the great thing about money is reading the values. It starts off with this value, and now it becomes this value, and now it becomes this value, and this value, and this value. It doesn't change anything in here, right? So a for each loop, what I want to do, right? My for each loop, it actually is the value of the item, right? How can I use the value of the item here? Can't do it, but it's great for printing. If I wanted to print the value of the item, like for example, I don't want to do this here, right? Let's extract this. I don't want to print it here. I want to print it somewhere else. Let me just display my cards. So I'll say display deck of cards. So here I just create the deck, right? And I want to use a for each loop to display them. That's easy to do, right? So I go for each, right? Here's for each. And look what it gives me. For each is, I have to declare my variable, item, whatever my variable is. In this particular case, I'm going to make it a string. So it's string, that's my first thing. My item is going to be called card, right? Now, see how my card, I already have it. So I'm going to say, I can't use card as an item. I have to say, I don't know. It's kind of tough because I've already declared card before, but card would be the right name, right? And here's deck of cards. So I'm checking each deck of cards. So I want to say for every card, for each card in deck of cards, right? And of course, I'm doing the same thing here, right? But I'm redeclaring it here in this local context. I can't use card because it's already been declared. That's why it's giving me an error. Let's say for every card with a capital C, for every card in deck of cards, right? Right. I want to print every card out. So I want to go console.writeLine, but instead of saying deck of cards card, I just have to say card. Right? Because card is taking the value of each of the deck of cards starting with the 0th index. And it's basically another way of iterating through the loop and taking that value, the value of each of the elements, and putting it into a temporary variable here. So every time it loops, card, this local variable card with a capital C, sorry I used that instead, is going to take the value of each element in the deck of cards array and plop it in here, the value. And I don't have to count, I don't have to know how many. I'm just going to go for each one. That's why I use the for each loop. Let's check this out and see if it works. Bam! Same thing. Okay? Same result. But another loop. So I've used like 3 different looping sections. First one for initializing it. Here it is. Right? the second one for, for creating the deck, and the third one for printing it. Hey, what about if I initialize it? Can I initialize it the same way up here? Could I say, card in deck of cards is equal to something, not just write it? I could. And of course, I would have to restructure this array up here, this for loop. So instead of faces, index, whatever, I could say do kind of the same thing. Let's restructure this one. I'm just going to make another loop so you see it a little bit different. It's the same thing though. The result is the same. For each, right? And my variable is going to be my faces, right? My faces are integers, right? For int, and I'll say faces with a capital, for face, capital F, right? In faces, right? Face, right, is equal to, and then, and this is the funny thing, I have to count somehow, right? I'm going through each face, right? And I have to have some kind of counter, which is really weird, right? Because I can't just add it on, right? I have to go like this. Watch. I'm gonna have to say int counter is equal. Sorry, instead of integer here, I'm gonna say counter. Sorry, I gotta think about how to put this in for you, so I don't confuse you even more than I've confused the crap out of you guys already. Counter. Okay, face is equal to counter, and I don't have counter. I've never declared counter, so I'm going to declare counter up here again as equal to. We're going to start off with 1, right? Face is equal to counter, and look what it says. It says cannot assign to face because it is a for each iteration variable. So I can't really do that, right? Because each of the variables, each time I go up face, I'm actually getting the value of my faces. The value I'm looking at. I'm not actually looking at the item, right? I'm printing out the value. So it's great for printing, but I can't assign. So I'm just trying to show you there's different ways of doing the same things. So this is correct because I'm displaying the cards. So I'm going for each card in deck of cards, write the card out. That's correct. Each card and deck of cards, write the card out, right? Each card and deck of cards, take the value of the card and do something with it. No problem. But you can't assign it, not through that kind of iteration. So that's what this thing does, kind of writes it out. And that's what the value of the for each statement is. So look what it says, use when you want to access every array element. And since the iteration variable is read only, you cannot assign a value to it. It's only a read only. So it reads each of the elements in the array temporarily, and you can use the printout or do whatever you want. And here's some for each loops with enumerations. Now in enums, I'll be honest with you, they're kind of a weird thing. We've talked about this before, right? Here's Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? Where if you remember, enums start at the value of 0, right? So if Sunday is really 0, Monday's 1, and so on. And then I say for each day, here's our string, day, in enum.getNames type of day, right? Get names would be which ones are these things, type of day. Console.writeLine day. So it actually writes out the name of the enumeration. So it would say Sunday, Monday, Tuesday in caps. Right? Not really a great thing, see? That's what the result is. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. We're going to stop it there for searching. There's different options for searching and sorting. We're going to learn how to search and sort in arrays. And arrays are quite complex and awesome, things you can do with them. Like you saw, I just made a deck of cards, right? Normally, without the array, I would need 52 variables for my cards, right? And each variable would have to be initialized as a string, right, that I would do manually. So a 1 of clubs, that would be my string. 2 of, clubs. 3 of clubs. All those things I have to write them manually if I didn't have arrays. Arrays is a type of collection. That's what it is. And what it does is it creates a group under the same name of similar elements, similar data types. That's what it does. And it puts them all together under one name that I can use an index or a subscript to go through. Okay? Huge, 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 huge learnings. And you know what? We're only on slide 15 of 49. Okay? Now I had to stop there because I did this big other example for you guys. And the reason why I wanted to do that for you guys was because that deck of cards example, right? We're going to build on that over the next several weeks. We're going to do deck of cards, until you're sick in the face deck of cards, right? We're going to do methods with decks of cards. We're going to sort and search and shuffle with decks of cards. We can do all the kinds of stuff because we're going to use multiple for loops, nested loops. We're going to do all kinds of stuff with deck of cards so you understand what's going on. We're going to see it over. Right now you're looking at it going, I don't quite get it. It's okay because you're seeing it for the first time. And arrays can be tough to get your mind around, right, until you start using them. Okay? So we'll end it there.